Hello, welcome back. Today I can't be bothered to go through the topics. I mean, all you did was series, easy stuff, just some algebra. So we're just going to be going through the assignment for today. Sorry it's a bit late. I'll have the CWC video out probably next week. And yeah, let's get into it. So, firstly, volume, just pi, square it, boom, done, and then you do some parts. Definitely recommend the DI method for this one. If you don't know it, you should probably learn it, because for stuff like this, doing normal parts is just long. So we're going to do all this. I pre-factorized it a little bit, and not that you need to do that, and then you just evaluate it. Question 2. This is a rule you have to know. So the modulus of two complex numbers multiplied individually is the same as the multiplied separately. So you can just find the modulus of z1 and then solve for modulus z3. Then you can find the argument. So again, this rule is kind of like logs, where when you're dividing them, you subtract, and then you solve. Because again, you find the argument of z2. Part C, find the values of a and b. Then you can. I actually didn't do the last part, but that's just easy because you just do the thing. But to find a and b, you say the modulus a squared plus b squared is 32. B over a equals tan of 3 pi over 4, because that's the argument, and then you can, after that, you can solve for all your values, solve simultaneously. And then for this little bit at the end, I forgot to do, you just divide them, and it's easy. Question 3. All you do is just set it equal to, so first you find the x corner where it intersects, and then you set it, you do y squared equals 1 minus x squared over 4, and then you're doing the integral of y squared dx times pi, and then you just compute that, get your answer. Part B, do the exact same thing except rearrange for x squared instead of y squared. Right, question 4. I could not be bothered to do, actually, to be fair, this is relatively easy to do in your head. You just expand this bracket in your head, and then you can see that it will be 5/2 of the of this right side here. Now, part B is an interesting one because you have to see that arc tan 4 over 3 is just the argument of 3 plus 4i, and then this is obviously the argument of 1 plus 2i, and then arc tan 3 is the argument of 1 plus 3i. Because if you see this, you can see that when you do the argument of these things, it will come out with this, and then you can then you do your argument rules with this, the ones we used a couple questions ago. And then you can use this result that you had to figure that out. But now you know that obviously because it's going to be arctan 1, which is going to turn into pi over 4. So this question is something relatively common, I guess. I mean, where you're just going to see the arctans turning into arguments. This is like a nice question. If you haven't done this yet, I'd be surprised. And if you're doing it for the first time now, I'd remember it, just because it's a nice result. You've been taught this in GCSE and you didn't really prove it, because obviously how would you do that at GCSE? But here you can, so x squared plus y squared equals r squared. Do the integral from r to negative r of r squared minus x squared, because you're rotating it around the x-axis. Then compute the integral, and then you will get that answer. Now we're back to normal stuff. So parametrics, do I dx, find m, blah blah blah, easy stuff. Part B, Cartesian equation. You just find y in terms of t and then substitute. Not easy stuff. Next thing, this is you just find the modulus, find the argument, but easy stuff. Now for multiplying the complex numbers, you just multiply. I mean, there's nothing really to say. You just multiply them and divide them, and then for dividing, you realize the denominator by multiplying by the conjugate. Part C, you multiply the two arguments separately, and then you subtract the arguments separately. Yeah, easy stuff. And same with this. So for this one, you divide the two moduluses or moduli, and then here you add them, here you subtract them. Question 8. Okay, so obviously because they're going to want us to rotate this, so we're going to firstly show this result, just expand, and then use the identity on it. You've seen something similar maybe when you're doing your A-level past papers on the 2022 paper 1. There was a question like this, where you had to do this in the question. And then obviously part B is just easy because it's using the result and then integrating. Question 9, which is literally the exact same as question 2, so we'll move on. Question 10. So here, because we're rotating around the y-axis, you need to find x in terms of y and then square that, and then you can obviously do all that you need to do and then solve. Question 11. This is kind of thing you saw last assignment. You know this is alpha, so beta is just a conjugate or complex conjugate. Then you can, there's a few ways you can do this, but I like to say this is the cubic. Obviously we have this, which is the cubic, and then this is the cubic. And you set them equal to each other, and then you could equate the constant coefficients to get q equals 28, p equals -7 after equating the other two coefficients, and then you get gamma equals -1/2 after doing the constant ones. Question 12. This is a bit of a weird one actually. So if you think about when you're rotating a straight line, you are going to get a cone. So you do the integral and you get this. How this works is that because if you have a distance h, the distance y, if you have y equals kx, where x is h, the y distance is just going to be kh because y equals kx and x is h. So if we're saying this is the volume of a cone where k is the gradient and h is the height, this would be r is just kh because r is the y distance. So you can just replace k squared h squared with r squared, which it doesn't really, you have to kind of think about it a bit. It's quite thought-provoking, I guess. Question 13. We're going to, this is like these questions are just really the same. So find modulus, find argument. Part C. This one's actually relatively cool. So we're going to put these on an Argand diagram, but very bad Argand diagram from me. I apologize for that. But you're going to see that when you plot this, this is going to be √2, and then this is going to be 1, and you can just show that angle because it's the two angles subtracted, I think. Oh no, sorry, this bisects this, so it's going to be 3 pi over 8, and then that's gonna work out to arctan, or sorry, tan 3 pi over 8, and then obviously that's going to be opposite over adjacent, or the argument of 1 plus √2. Question 14. We're going to have, simple stuff, just differentiate. And then part B, exact coordinates of Q, just set it to 0, solve your trig quadratic, and then substitute, find theta, and then substitute back in. Part C, this is a bit of a weird one, I remember. So you can factorize 2 cos theta. So if you turn sine 2 theta into 2 sine theta cos theta, you can factorize 2 cos theta out of the y1. And then if you turn them all into sines, so turn the cos into √1 minus sine squared, you can square both sides to get y squared equals that. And then did a little bit, I put the 4 in. And then now, because we know that x minus 2 equals 2 sine theta, we can substitute all the sine thetas in for x minus 2. And then you do a little bit of algebra and eventually you'll get the answer. And then part D, you just volume revolution, easy stuff. Question 15 is the exact same as question 4. And then now we can move on to assignment 2B. Okay, this is a bit of a more like procedural assignment. So one is just sketching all the complex numbers. If you just think about, well, you can just read from the diagram what the complex numbers are and just do it manually. And obviously you can figure out the patterns by just doing the diagrams. Question 2, just finding the modulus in the argument. Just notes for B. This, you can turn B into this because of the properties of cos and sine. Just know that when you see a minus here instead of a plus, you're going to have to do this, because cos of negative x is cos of x, and sine of negative x is negative sine x. But then all of this is fine. Question 3. This is just going to be, again, so for the argument, for the modulus you multiply them, and for the arguments you add them. Part B, same thing, you just divide the moduli and then subtract the arguments. Question 4. Yep, conjugate. I mean, this is just simple stuff. You just blah blah blah. Z over Z star. Just gonna multiply by the conjugate again, find your answer. Part B, again, just finding, like, multiply by the conjugate and then finding the conjugate of that entire thing. And then multiplying them, you just do a squared plus b squared, and that'll give you 1 over 13. And now part C, we're finding what z is in form a plus bi, given these equations. Z star is just a squared plus b squared, and z plus z star is just 2a, because the bi's will cancel, and then you can find a from that and then substitute back in to find b. Yeah, that was actually a lot easier than I thought. Question 5, again, I mean, conjugate, same thing. Write down the other root. Well, oh, that was the same thing, sorry. And then if you remember, when you're doing these things, you can do the sum of the roots. B is going to be the negative of the sum of the roots. C is just going to be the product of the roots. B, same thing I did in the pre question on 2a. You write out the cubic like this, set it equal to this cubic, and then you can equate the coefficients of each term to find your values. Question 6. Yeah, just do what it, honestly, just do what it, there's a lot of this assignment is just do what it says, to be honest. There's nothing that complicated about it. Part B again, find the modulus of that, easy stuff. C, you're just verifying it. Yeah. Then part D, doing the Argon diagram, nothing too complicated. Question 7, again, just calculate, same stuff. If there's anything 1 over or complex number divided by each other, you just do the conjugates. Next, find the modulus of all of them. Nice, really fun stuff. Then this question is a bit of a weird one. So if you show all these points on the eigen diagram, you can see that this modulus here is 18, so therefore this is going to be this length is going to be 18. You can see this is 3 root 2 because the modulus of this is 3 root 2. And then if you find the modulus of C, then, or if you use the modulus of C, sorry, or 1 over Z, you can see that this is just going to be a multiple of each side. It's going to be a multiple of a different side. I didn't do every single side, but you could, by doing like the modulus of every single length, doing the modulus of every single length, you can see that all the sides are going to be 6 times larger than the other ones on the respective triangles, therefore it's going to be similar. I just realized I didn't actually mark this. Oh, that's actually annoying. Well, I did mark it, but like I didn't tick anything. So question 8. Again, conjugate. The module, I think this one was a bit of a weird one. I think I put in like the num-works and stuff, and it gave me a different answer. So make with that what you will. Part B, another like find the value of the complex number. So x equals y, and then yeah, sorry, this should be arctan y over x equals pi over 4, and then solve blah 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 blah. Yeah, because the I component, the imaginary component is going to be equal to the real component, so you can set them equal to each other and solve. Question 9, differentiate, tangent, blah blah blah, easy stuff. The area of this triangle is just, you find where y is 0, find where x is 0, and then find the area. Not very complicated at all. Question 10, there's some differential equations, just like differential equations until second year is just the exact same. All you're doing is just separating the variables. Yeah, and then you're just going to get this. Sorry, a is not 0, a is 1. I don't know why I put that there. Next one, blah blah blah, differential equations. You're going to get an integration by parts on this, and then part 11, trick stuff. I mean, you guys know how to do this. Honestly, this is just stuff from normal A level that you've done already. You can just do the reverse of the the tan double angle formula, and then when you add them, when you combine the fractions, you'll see that, when you separate the fractions, you'll see that this just cancels to cot. Part B, this is a nice one because you do the fraction, you see that this simplifies to, well, the denominator goes to half sine 2x, the numerator just goes to sine 2x because it's sine 3x minus x, and it expands to that compound angle form. I haven't seen a series in a while, so just dividing, taking the common ratios equal to each other, solve. Easy stuff, finding sum to infinity. So given that the sum converges, well, if the series converges, then the last term as the sum approaches infinity will be 0. So for a geometric series, So if the sum is going to approach either infinity or negative infinity, then it's going to diverge. If it approaches 0, then it will converge. So if you substitute values in, you'll see that 15 is when it converges, and then 2 is when it diverges. So yeah, you're going to do sum formula. Part B, the common rate. This is the common ratio multiplied by itself 3 times is just going to be 24 over 81. Obviously, you could solve simultaneously, but this is just a quick way of doing it. Then solve for A, sum to infinity, blah, blah, blah. This is a funny one just because it's just a bit stupid. So you just find U10 and then log it, and it simplifies. This is quite a funny one because part 13a, they probably wanted you to use the sum formulas for k squared and for 2 to the k, but because k squared would just be 1/6 n plus 1 to n plus 1, where n is 5, and then this would you just use the geometric series formula, but you can just add the terms because it's up to 5. Part B, you can use just the normal arithmetic series formula, common difference to first term 19. Then part C, the same thing, first term 108, common difference -3. Yeah. Question 14, another differential equation, another integration by parts, same thing. And then lastly, 15, it wants you to find all these points. So you find 2 of them by finding where it intersects, and you find the other one, we find one of them from finding where it intersects the y-axis, and then you find the last one by finding the stationary point and seeing that that's going to be t equals 4, but that's going to give you this stationary point, which we already found up here, so it's going to be the other one, and therefore this will be this point, because you can substitute that t value back in. Okay, thanks very much for watching. I will see you guys in CWC, and then I'll see you next year for the next year's assignments. Goodbye.